Hi, this is a quick video on how to calculate angular speed. So hopefully you've watched the PowerPoint by now. Here's the video of how to do our first problem. So again, we're going to use our 6 steps. What am I looking for? Looking for angular speed in radians per second. So my formula starts like this. I'm going to call that W. You can call it whatever you want. In physics, they call it the lowercase omega. I'm going to call it W equals circle line over T. If you really want to know all the Greek, this is omega theta over time. So we know that circle line is the number of revolutions or radians. In this case, it's 696. Don't forget to write units, revolutions, over our time of 12 minutes. And we know that revolutions per minute are acceptable at this point. I know we're still shooting for radians per second, but we'll get to that conversion in a second. So as we move forward here and we do that math, we end up with 58 revolutions per minute. Now, to convert that to radians per second, remember, we have a conversion of 0.105. I'm going to use the thumb chart to do this. So here's my thumb chart of 105 as our conversion factor. And we put our REMPMs down here, or RPMs, and radians per second on top. So we're looking for radians per second. So remember, we cover that up with our thumb. We end up with RPMs times 0.105. So we take this times 0.105. And again, we took that from our thumb chart. We do that math. We end up at 6.09 radians per second. Now, remember, this is a vector because we have motion and a magnitude in a direction. So being that we have magnitude and direction, this is a vector, which means we have to state that it's a vector. Remember that counterclockwise is our direction? Well, from the PowerPoint, we learned that counterclockwise is a positive number, so this is our finished answer. If this were clockwise, CW, then this would have been a negative number. But because it's counterclockwise, it's a positive number, it stays this way. And that's our final answer. So to quickly review, my formula is circle line over T, or W equals circle line over T. We typed in our numbers of 696 revolutions over 12 minutes, which I took from here. We did that math and got 58 revolutions per minute. We multiply that by 0.105 because that's our conversion factor to get from RPMs to radians per second. Because remember, we're looking for radians per second, so we cover that up. And it's RPMs times 0.105. We do that, we end up with 6.09 radians per second. And we pay attention to our direction. Counterclockwise is positive, clockwise is negative. That's why this number remains positive. Hope that helps.